from the town of Springfield. He's about to hit a chestnut tree.
Epicycles are just so awesome. The math behind them, their applications, the history of epicycles, just everything about epicycles is... Epicycles showed up for the first time in physics and mathematics around the 3rd century BC to explain the apparent retrograde motion of planets in the night sky. When you plot the positions of some planets against the stars, it seems that sometimes they go back and then they go forward. And to be able to explain that from the Ptolemaic system, where Earth is at the center of the universe and the planets are circling around Earth, then you have to come up with some crazy equations that would explain that, and they used epicycles for that purpose. As astronomers collected more data, then they used more and more epicycles to be able to model the actual motion of the planets in the night sky, to the point that by the 16th century, the models used something between 40 and 60 epicycles to model the motion of one planet, which was just insane. All that came crashing down when the heliocentric system came around and explained the motion of the planets in a much easier way. Epicycles is the motion that you get when you go around in a circle, but then you can add another circle to that motion. So the object going around in the bigger circle is also going on a circle, and then you can add another circle, another circle, another circle, and see what kind of motion and graphs you get with that motion. So here you can see the epicycles with 1 cycle, with 2 epicycles, with 3 epicycles, with 4 epicycles, and depending on the constant that you use in the equations of the epicycles, then you get, well, different types of motion. But why were epicycles so effective at modeling the retrograde motion of the planets? Or why are they so effective at drawing something so complex as the head of Homer Simpson? The reason is Fourier analysis. Fourier analysis tells me that well-behaved functions, such as smooth functions, have Fourier series. And what that means is that the function can be approximated by sums of trigonometric functions, and in fact to an arbitrary precision. And since adding epicycles means that I'm just adding more and more trigonometric functions to the parameterization of my curve, if I want to approximate just any curve, I just have to come up with a Fourier series and then cut it off to as many epicycles as I want, and that will give me a very good approximation of the curve that I want.